Hi guys, a lot of people requested a video for this classwork, so here it is. We are going to learn about different kind of transformation in this classwork. Um, Last week we talked about vertical translation, horizontal translation, and we're done with all the translations. And now we're going to focus on reflections. And what reflections are, there are two kinds. We can reflect something over the x-axis or over the y-axis. So in this classwork, we're going to learn what the difference between those two are and how we can write that using function notation. Let's look at number one. Here is the graph of function f in the table of values. So we want to find f of x and fill it out. So for the table, x values are already filled out and we just have to fill out the f of x part. But before we do that, I want to just quickly go over the function notation one more time. So if I have f of x, this entire thing represents the output, and whatever goes inside the parentheses will represent input. So if I look at the first row of the table, it says x is -3. So the input is -3, and we're looking for f of x, which is output. So basically, we're looking for f of -3. What happens is find output when input is -3. And then that f just represents the name of function. So there's a function named f, this one, and then we just want to find the outputs given the inputs. So if you look at the graph, the output was 0, -4.3, -4, -1.8, 0, 3.9, and 0 again. So I'm just going to copy that onto my table. Alright, so now we want to look at g of x, the new function. So we don't have a graph for g of x, so we can't just copy the points. But if you look at what g of x is g of x equals to negative of f of x. So we already know what f of x are. So the second column, so let me highlight that in blue. The second column represents the outputs, the f of x, and g of x is just same as negative of all those f of x numbers. So for example, g of -3 is negative of f of -3, which is -0, right? But there's no such thing as -0, so it's just going to equal to 0. For the second row, it's going to be negative of -4.3, which is going to be positive 4.3. Third row is going to be 4. Fourth row, it's going to be 1.8. 0 is just 0. And then negative of 3.9 is -3.9, and then 0 is going to be 0 again. So we have two different functions. Let me show you what happens if I graph those points. There you go. So the f of x is the green graph. This is our original. Green one is our original. And then red graph would be our g of x, which was negative of f of x. So you see on the graph that all the x values have stayed the same, but all the y values have been opposite signs of each other. So what I mean by that is, see, the x values are the same. So if I draw a line, it goes through the both points, right? So this point, for example, would be negative 1.5, comma 4.3, and this point will be negative 1.5, comma negative 4.3. So you see that the x values are staying the same, but the y values are the opposite signs of each other. And we would call this transformation reflection across the x-axis, because this x values have stayed the same. Go to this link and check your answers, describe what happened to the graph. So basically we know that it's going to be reflection across x-axis. So you can think of refraction across the x-axis as flipping it upside down. So now we need to learn about a different kind of reflection, which is obviously going to be reflection across the y-axis. And let's see what it means by that. So we have the same function f, it's the same graph as previous page, and now we have a different rule, different function. It's a function h, and h of x equals f of negative x. So what I want you to notice is that now they're not changing the output, right? But what they're changing is what's inside the parentheses. They're changing the input. Input change. So whatever x's input is, f of x's input is, you're going to put a negative sign in front of it, and you will get the new input for h of x. So let's see, let's use this equation to find h of 0. So we see that input is 0, and then it's asking us to find the output of function h when input is 0. So h of 0, we're using this equation, equals f of negative 0, but f of negative 0 is same as f of 0. So if you look on the graph, f of 0 would be negative 1.8, so h of 0 would also be negative 1.8. How about h of negative 0.6? We know that inputs are going to be changed. It's going to, so right now, x is negative 0.6, so f of negative x, we know that the input of f will be negative of negative 0.6. So it's going to be positive 0.6 because two negatives make a positive. So that means h of negative 0.6 is actually equal to f of 0.6. And f of 0.6 on the graph, we know that it's going to be 0. So we can say that our prediction for h of negative 0.6 is equal to 0. And that's our answer. All right. So let's figure out the rest of the points for h of x. Filling out the table for f of x, I just redrew the graph the table over here because I took a screenshot and then I can't get rid of these answers, so I just redrew it. But anyway, the f of x table is easy to fill out because we just have to copy down the y values. 0, negative 4.3, negative 4, negative 1.8, 0, 3.9, and 0 again. So now what we're going to do is we're going to change the inputs. Because h of x equals to f of negative x, we're changing the inputs and we're changing the signs of the inputs. So now if you look at the h of x table, the first row, the input for f of x used to be negative 3, blue, I guess. But now we're changing the input, we're doing negative of negative 3, so that means my input here for h of x will be positive 3. And then the second row, input used to be negative 1.5, but since we're making the negative 1.5 negative, so negative of negative 1.5 would be positive 1.5. and then the trend just continues. We're making the inputs negative. And then if you look at what happens to the output itself, it's not changed at all. There's no negative sign in front. We're not adding anything at the behind the f of negative x. So the outputs actually stays the same. So the only thing that changed, as you can see, is the input values and how they are now negative. So let's actually graph that table, f of x and h of x, and it looks like this. So the green one is again the original, which was f of x, and then the blue one is h of x, and it equals to f of negative x. So as you can see, the green graph has been flipped left and right side. So left side, where used to be left side here, is now on the right side. And what used to be right side on the green graph is now on the left side of the blue graph. So this reflection is called reflected across the y-axis because as you can see here, like the y values of the points are the same. If I draw a line like this, we see that the y values are the same, but then the x value has been switched. So for example, this point right here, it was negative 1.5 comma negative 4.3, and that same corresponding point on the blue graph, the h of x, is 1.5 comma negative 4.3. So look at the x and y values. We see that the y values are I thought that was a highlighter, sorry. You see that the y values are the same, but then x values have changed signs. So think of reflecting across the y-axis as, let me draw. So this is your hand. So let's say you're holding the x-axis like this. Oh, there's some fat fingers, hold on. Okay, whatever. So you're holding the x-axis like this, and then imagining you pushing this hand backwards and pulling this end like towards you. So we're literally flipping the x-axis around. That's why the x-axis have changed signs, because here the positive x-axis is going to go to the negative side, and the negative side of the x-axis is going to the positive side. We're flipping it. So that's why the x-axis are flipping the signs, because we're reflecting across the y-axis. Sorry. So let's look at the cooldown. Describe the transformation of f to g given by g of x equals negative f of x, and fill out the table. So let's, oh my god, okay, there you go. So let's look at the graph. We have 3 given points, and we have a weird looking W-shaped graph, and we see that the rule, the transformation that they gave us was g of x equals negative f of x. So that means we're changing the output. The inputs stay the same. We're changing output. And since we're changing output, we're changing, aka y values, we're changing the y values. Oops, I forgot to write the answer for number 4. Let me go back and just say reflection across y-axis. Okay, so let's come back down to the cooldown. It says we're changing the output, we're changing the y values. That means we are flipping the flipping the graph upside down. So that means whenever, since we're flipping it upside down like this, and this side up, what that means, the inputs stay the same, and only the output, the y values, are changing signs. So the inputs should stay the same. So I'm just going to write down all the inputs first: negative 1.4, 0, 0.7, and for the y values, wait, let me erase one of the arrows because you can't see. Okay, if you look at the y values, it used to be negative 0.8, 2, and 1.6, but now they're going to change signs. So negative of negative 0.8 will be positive 0.8, and then positive 2 would now be negative 2, and then 1.6 would now be negative 1.6. So why is it not erasing? There you go. So let me actually graph that on the same axis for you to see what it looks like. When x is negative 1.4, y value was 0.8, so like right here, and then negative 2, and then 0.7, comma, negative 1.6, so like right here. So if I connect the dots, I have the graph to be, oops, like this. So you see that it's the exact same graph, except the only thing that changed was the graph was flipped upside down. So this is a reflection across x-axis. So the name of the transformation tells you what stays the same. So when we're changing the y values, it's actually a reflection across the x-axis because x-axis stay the same. So be careful with the names because they don't tell you what's changing, they tell you what stayed the same. Number 2, I'm going to use blue. So we have another transformation is h of x equals f of negative x. So what that means is that the inputs are changing. Input was x, and now we're making it negative x, and the output stays the same. So what we're trying to do is we're trying to reflect the graph across y-axis. So that means we're flipping the left side to the right side to the left side. So that means since the output stay the same, I'm going to copy down the output of our original graph. So it would be negative 0.8 to 1.6. But the input values are going to change. So when input used to be negative 1.4, now it's going to be negative of negative 1.4, which gives me positive 1.4. When input is 0, negative 0 is just 0, so that's going to be the second row. When input is 0.7, it's going to be negative of that, so it would be negative 0.7. So what that actually looks like is, hold on 1 second, let me draw that. Here, and then here, and then, alright, here. So now the graph looks like this. So comparing it to the original graph, the black one, if you look at the blue graph, we see that the outputs have stayed the same, but the inputs, the x values, have been switched, and it's a reflection across the y-axis. So we learned about 2 different transformations today, well, to be exact, 2 different kinds of reflections. And this is what happens when we do reflection across the x-axis and the y-axis. So the highlighted in red, it's how you write in function notation. And then across the x-axis is changing it upside down, changing the y values. Across the y-axis means left and right, and it's changing the x value. And actually, let me add to that a little bit. So if you reflect across the x-axis, x value stays same. The name tells you what's staying the same. So, and then y value stay the same if you reflect it across the y-axis. Stays same. So this table will be very useful to you when you do the homework. So if you want to take a screenshot of that, that'll be great. Thank you.